In Core 1 today, we are continuing to look at quadratic functions involving pumpkins. Okay, yesterday we looked at pumpkins falling from a roof of a building. Today we're going to look at pumpkins being shot out of a cannon. So this introduces a couple of new elements to it. Now, the problem that we did in class was as follows. Suppose that instead of just being dropped, a pumpkin is now being shot into the air with a cannon. The cannon is 20 feet tall, shooting the pumpkin straight up at a velocity of 90 feet per second. Its height is represented by the equation below. So I gave you the equation y equals 20 plus 90t minus 16t squared. Now, as you can see, the 20 comes from the 20 feet tall. The 90 comes from the velocity. Now, it has a time attached to it because you go 90 feet every second, therefore it needs to be multiplied. Now, the 16 is our gravity constant. So no matter what, we're going to use that 16 if we're dealing with feet and an object falling because of gravity. Now, we have two positive numbers and a negative number because these two refer to it being up. Gravity is the only thing bringing it back down. So these two are positive. This one is negative. If we don't have that negative, then the pumpkin's never going to land on the ground. So that's where our three numbers come from. Now, first up, we wanted to take a look at a table. So our table has time on top and height on the bottom, and time is in seconds and height is in feet. Now, our table was only big enough to show when it hits the ground. So, let me set up my table. At 0 seconds, our pumpkin is still in the cannon. Therefore, it's at 0:20. Then we went 1, 2, 3, 4, 5, and 6. Now, let's look at how to do this by hand first before we look at the calculator. Plugging in a 1 means I have y equals 20 plus 90 times 1 minus 16 times 1 squared. 90 times 1 is 90, 20 plus 90 is 110, 16 times 1 is 16, 110 minus 16 is 94. Okay, let's do the other one. Y equals 20 plus 90 times 2 minus 16, 2 squared. 90 times 2 is 180 plus 20 is 200. 2 squared is 4 times 16 is 64. Minus 64. 200 minus 64 is 136. So you can see how this just becomes a little repetitive. Now, let's take a look at a calculator to do the rest for us. So, I'm going to take my calculator. First thing I'm going to do is clear it. Second plus 712. Now, in the y equals, I'm going to plug in my equation. 20 plus 90x, the calculator has to deal with x, not t, minus 16x squared. If we look at our table, it's going to have all the information we need. 0:20. 194, 2 136, 3 146, 4 124, 5 70, and 6 negative 16. Now our height just hit negatives, which means the pumpkin has gone below the ground. So obviously it's hit the ground by then. Now, if we want to take a look at our graph, it's not going to show us a whole lot because our window's not very well. Okay, we can tell that obviously it goes something way up here. Now, the highest number our table says is 146, so what I'm going to do is tell the window to go a little bit higher than that in the Y max, go up to 150. Now our graph is going to look different. Whoops, I typed in the wrong number. Not Y scale 150, Y max 150. There we go. Now it looks like the pumpkin being shot in the air. So our graph looks something like this. Now, it makes sense because this is a negative quadratic. So it is a frowny face parabola. Now, the other two things I asked you to find was the maximum height, which is this right here, and how long it takes until it hits the ground, so right when it hits the ground again. So the max and the ground. Now, the way we've been doing this in class is by looking at our table. Now we know the max, well, it goes 136, 146, 124. So it's somewhere around 2, 3, and 4. So I'm going to go into my table set, start at 2, and I'm going to count by 0.1. Now, if I look at my height, it goes 136, 145, 146, 146, 146, and back down. Looks like the highest I get to is 146.56 feet. Now, we can see it's going back down, so if I just go back down a little bit more and figure out close to where it hits 0, that will be our answer to when it hits the ground. Almost there. Somewhere between 5.8 and 5.9, it looks like 5.8 is the closest, so 5.8 seconds to hit the ground. Now, that's all today. We're going to be continuing this work for quite a while with problems just like this.